Alright, let's take a look at Leetcode 780 reaching points. And I actually saw this exact question on a Twitter hacker rank. It wasn't as tough because the time constraints were a little bit easier, so I didn't have to do the last optimization step that I'm going to show you. But on Leetcode, it's a little bit stricter, so you will have to do some clever optimizations. So let's see the problem. So basically, we're given a SX and SY, which is our starting XY coordinate, and then we have to see if we can transform that into our target XY, TX and TY. So we just return true or false if we can go from the starting point to the ending point. And so at each stage, we're given two possible choices. We can either transform the XY into x plus y, or we can transform it into x plus y, y. So we can, I've drawn out an example here. So basically, we have the source as 2.5 and the target as 19.12. So you can already see that this is going to be a branching, like tree type of structure, right? From 2.5, we have two options. We can either do the first option they gave us, or we can do the second option. And so, right, if we do that first option, we get 7 and 5, right? Because x plus y, 2 plus 5 is 7, and then the y stays the same as 5. So we have 7, 5, and then the other option is here. You can work it out yourself, right? So ultimately at each location we can have two more options, and so basically this kind of recursive approach would be of the magnitude of 2 to the n, because at each location we can try two more paths. So that would time limit exceed if you wanted to go from the source to the target and try to find it like that. Another approach, so a clever approach that people have said in the discuss section is actually the approach that you need to take, and it's instead of working from bottom to target, you have to work from the target to the start, from the back to the start. So you might be thinking, how do we know what the previous step was if we work backwards? Well, it's actually pretty straightforward, I think. So if the x value is larger than the y value, then you know for sure that you had to have used this equation to get from the previous step to the current step, right? Because basically, if you subtracted the y, then these values would be the same. But yeah, pretty much this equation always ensures that the left side is greater than the right side, right? Because if you're adding, because these are all positive numbers, so if you add some x value to the y, it should definitely be larger than the y itself, right? So that's why we know that this 1912 definitely came from 712. And how do we calculate that? Well, I have the equation here. And yeah, so basically this is the pseudocode, and you can express this as if tx is greater than ty, which it is in this case, then you just subtract equals ty, right? So that just looks like 19 minus equals 12 is 7, and so that the new x value is 7 and the y value doesn't change, so then it's just 12. Right, so same logic applies for ty the other way around, right? Because at the next step, the y value is larger, so we just do, so the new y value is going to be 12 minus equals 7, which is equal to 5, and then our x value is staying the same. So that's how we get 7.5 as the previous step before 7.12. And this way we just work all the way down to the root. So this is a pretty good approach, right? We were just going in one streamlined direct path from the end to the start. But even this will time limit exceed. So let me show you an example where this is not very optimal, and there's a way we can make this faster than just subtracting each time, right? So let's say the source is 19 and the target is 109. So I think it's pretty obvious that, since this y value never changes, we would just keep, adding to the y. We would keep using this equation, x plus y every time, and then eventually from 1 you can transform that all the way into 109. So, if we did the subtraction method, minus equals ty, right? You would go from 100 to 91 to 82 to 73, blah, 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 all the way down to 1. So actually, what if I told you you could skip all these in-between steps and get straight from 109 to 19? So instead of subtraction, so take a look at this pseudocode again. What we can do is we can use a modulo. So in this case, it would be 100 modulo equals 9, which gives you 1. So our new x value is 1, and then our y stays the same as 9. Right? So we got from 109 down to 19 immediately. So that is the optimization that we're going to take here. So so that alone, you're still going to have to check another edge, like 2 edge cases, if you use the modulo, because let me show you an example where the modulo will screw you over. So let's take a look at this example here. What the heck is wrong with my mouse? Okay, so let's say the source is 3.3 and the target is 21.9. So starting from 21.9, let's first use the modulo. So we know x is larger, so the first thing we do is 21 modulo equals 9, which gives us 3, and then our y value stays the same, so that's just 9. So immediately we can just go from 21.9 to 3.9. So right, the modulo helped us skip this in-between step. And then after this, now let's try to do the same thing for the y value, right? So the y value is larger than 3, so to calculate the new y value, we do 9 modulo equals 3, which actually gives us 0, right? So 0 is not the right answer, right? Because actually it is possible to go from 3.3 to 3.9, isn't it? Right? Because you can already see I drew out the diagram. We can go from 3.3 to 3.6, and then from 3.6 to 3.9. But if we used a modulo here, then that would actually screw us over and give us a 0, right? So 9, so basically if we use the modulo, it would return false, meaning we can't go from 3.9 to 3.3, and that's just not true. So instead, what we have to do is, once we, so all of these, right, this pseudocode, this all happens in a while loop, right? So you just keep while looping until your x and y value are less than the source, right? So at each call, what you can do is, so the 2 edge cases I'm about to tell you right now. So basically, if your values match, if one of your x values matches the source's x values, then you can isolate the other side. So right here I have the case 3.3. So the source is 3.3 and the current location I'm at is 3.9. So since the x values match, the 3 and the 3 match, we can just isolate the y values, so 3 and 9 here. And then so using 3 and 9, we have to try to see if we can get 9 down to 3. Right? So the way we do that is we're going to, so the trick here is to do, what you're going to want to do is 9 minus that 3, which gives you 6, and then 6. So using 6, we have to look at the tx value, which is 3, and see if 6 is divisible by 3. So if 6 is divisible by 3, then that means if 6 modulo equals 3, if 6 modulo 3 equals 0, then that means we can return true. So I think it's hard to see the pattern with these 3, 6, 9, but let me show you a better example. So I have a better example right now here. So basically, the point of this is if the current number you're at, so let's say we're at 211 and our source is 2.3, so since these 2's match, the x values match, we're going to just isolate the y values, right? 3 and 11. So what we're trying to express here is, can 11 somehow get down to 3, using these 2 numbers and the 2 equations that they gave us above, right? So it can get down to 3, and let me show you how, right? So like I said before, what we're going to do is 11, we're going to subtract, we're going to find the difference between the source y and the target y, which is 8, right? 11 minus 3 is 8. And then if 8 is divisible by this x value here, and why do we check if it's divisible by this x value, it's because at each stage, right, what we're doing is pretty much just x and then x plus y, right? So we can just go from 3 and then just add 2 each time to get up to 11, right? So that's why using a modulo to check this is basically checking if you know, we can go from 3 to 11. So basically, you know, you find the difference, which is 8, and then 8 is divisible by 2, you know, the x value here. So that means it is valid. And then if you know, if you find out that it is equal to 0, if the modulo is equal to 0, then you can immediately just break out and return true. And same goes the other way. Like if this were 3, 2 here, and then this were 11, and then this were 2, and you just flip-flop everything, right? This is also going to same exact concept, right? If these y values are the same, then we isolate the x values, right? So 11 and 3, so we find that the difference between 11 and 3 is 8, and then 8 is divisible by the other counterpart of our current number. So that means there is a way to go from 11 down to 3, because we just subtract this 2 every time. Or if you want to look at it from the more formal way, basically from 3 we just add the 2 every time to get to 11. So you know it's valid. Okay. So yeah, I mean, try your best to go and implement that. I'll have the code in the description, so yeah, check that out if you need to. I think there's a couple of good posts in the discussion section, but I felt like, you know, it was still kind of hard to understand for the most part until I kind of just played with it myself and then looked at some examples myself for a bit. So yeah, just try your best with this question. Honestly, I wouldn't expect this in like a phone interview or anything. This is like it's kind of asking if you know this trick or not. It's not really asking you about data structures or algorithms. But yeah, I mean, I did see it in a Twitter online assessment. I think online assessments, anything is fair game, because they just throw anything at you in an online assessment. Those are hard as hell. But yeah, all right. Hope you guys learned something. Give it a shot and check out the code in the description. Thanks for watching.